Okay, this video picks up lesson 4.2. It's for anybody that was absent on Monday, November the 16th, or was busy taking their test during class, or it's also for those who were in hour 4. Hour 4, as you'll recall, was interrupted with lots of announcements and a quick meeting with Mr. Norton. So if you were absent taking your test during your class period, or you're in hour 4, then you need to watch this video. All right, so I'm just going to start at the beginning of graphing, and hour 4 you can scroll ahead until we get to the place where we left off in your notes. So we're going to go ahead and graph y equals 2 to the x, just like we did in lesson 4.1, where you pick x's and find your y's. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, 2, 4. And this is something you would have been graphing in lesson 4.1. I'm going to call him A. All right. I'm going to now take this and set it equal to y. And I'm going to switch it to logarithmic form. So my base is 2, my exponent is y, and that equals x. Well, I can quickly see that if I write this as y equals 2 to the x, that we're talking about inverses. So one way to graph 2 to the y equals x is to simply take my xy chart from up above and just flip my x and y around. But you need to stop and realize that for a lot of the graphing problems, I'm not going to ask you to graph the inverse function first. I'm going to ask you just to start by making a graph like this. And if that's the case, you're going to have a game plan that doesn't include graphing the exponential function first, like 2 to the x. So your game plan would be to select your y's, and plug them in and find x. So it's basically doing things backwards. This equation right here is solved for x. So you're going to choose y, find x. It will be true that these two tables will be the reverse of each other. 2 to the -2 is 1/4, and then 1/2, then 1, then 2, then 4. And there's your inverse function. So this is the graph of, let's see, I should have called that F, and this one is your G. Now it's true that they're inverses, so we have that line of reflection, y equals x. And that's mentioned here in the text. Okay. In class, we looked at this slide briefly. This is the graph of log base 8 of x equals y. A is positive, and we talked about the fact that it's an increasing graph, that it's got a vertical asymptote at x equals 0. It's 1 to 1, it's increasing, and so forth. And this is where we stopped in hour 4. So this is kind of where I'm going to pick up with them. And so the first thing we're going to do is we're going to take and graph this function on each grid. So this will be the grid for A, and this will be the grid for B. So if I'm going to graph f of x equals log base 3 of x, the first thing I'm going to do is set it equal to y. And then I'm going to take and write it as an exponential. So that will be 3 to the y equals x. From there, I can do an xy table. Remember, this equation solved for x, so I'm going to pick my y's first, plug them in, and graph. So 1/9 -2, 1/3 -1, 1 0, 3 1, 9 2. And I'm going to go ahead and put that on each grid. And that's F. To get G graphed, we're simply going to do a translation. So this adding 3 inside the parentheses moves our graph left 3, and subtracting 3 outside will move it down 3. I'm going to do those graphs in this pink color. So I'm going to take my original function here and move it left 3. And so on. Now what's going to happen is you're going to have a vertical asymptote here at -3. So your graph should not cross that. That's a boundary. All right, so that's function G. Now they want you to name the domain. So if you know that x equals -3 is a vertical asymptote, your domain is pretty straightforward from there. And your x-intercept, if it was at 1 0 and you moved it to the left 3, it's now going to be at -2 0. And you should be able to read that ordered pair that I have highlighted. All right, for B, I'm going to take and shift my graph down 3. 1 2 3. 1 2 3. 1 2 3. And when I do an up and down shift, a vertical shift, that doesn't change my vertical asymptote or my domain from the original. However, it will change the x-intercept. Now you can't see my x-intercept, but as my pink graph continues to the right, it will keep going up. So to find your x-intercept, what I need you to do is I need you to set your original equation equal to 0. I'm going to add 3 to the other side. We're going to take our base. This is our base. Our base is 3. We're going to raise it to the exponent of 3. So we raised it to the 3rd power, and that equals x. So our x-intercept is 27 0. Okay. From here, we went to the natural log function. And we talked about the fact that back in lesson 4.1, when we graph the natural log function, so this is 4.1, we have the graph right here. So this is the graph of y equals e to the x. When we look at that graph, it does pass the horizontal line test. So every line that intersects it at one time. That's every horizontal line. So it does have an inverse. If I flip my x and y's around, I'll have this. If I write that in logarithmic form, I'll have log base e of x equals y. Remember, it equals your exponent. And log base e is defined as the natural log of x. So now we have this ln function. It's called a natural log. So I'm going to go back to 4.2, and that's what I have circled right here. So the parts that you need to write in your notes are highlighted in yellow and circled or written in the pink color. So that needs to be in your notes. This right here is what I was just showing you in lesson 4.1. You can only take the natural log or the logarithm of a positive x value, so you do have to have that x is greater than 0. Okay. This is the graph of e to the x and the inverse, so you can see that they're both symmetric again about the line y equals x. I just had the kids look at this in their notes. They didn't necessarily have to have it in their notebook. We went through these little examples where you're just plugging in the values in your calculator. So you would be finding the ln of 2 here, the ln of 0.3 here, and so on. And then on the next slide, we just checked our answers. So that's just a check to see if you can use your calculator. We skipped this. We're going to do that in the next video. We skipped that. And we went on to graph the natural log function. So these are all things that we did Monday in class. So fourth hour, if you would have had more time with me, we would have graphed this as well. Now, when you graph the natural log function, you may use your calculator. And so we're going to start by graphing this. This will be our parent function. All right, you need to remember that x can be greater than 0. So basically 0 is your vertical asymptote. So as you pick values for x, you might think, well, the only thing I can pick then or the first thing that I want to pick is a 1 and 2, maybe a 3. Maybe you want to do 10. So anything bigger than 0 is going to be fine. However, you might overlook the fact that you could also do 1/2. Or you might do a 1/10, but you can get really, really close to 0. So what I would do is choose a few x values close to your asymptote. In this case, that's x equals 0. And then the rest of your table can just be larger values. And then you're going to plug them directly into your calculator and get your y values. So I do want you to use your calculator here. So I'm getting mine turned on here. So I'm going to do the ln of 1/10, and that's negative about 2.3. Then I'm going to do the ln of 1/2, and that's roughly negative 0.7. The ln of 1 is 0, and that's a fact that you're going to want to memorize. And I forgot, another one that you could use is e. The ln of e is always going to be 1. And then back to our table, the ln of 2 is about 0.7. The ln of 3 is about 1.1. And the ln of 10 is about 2.3. So you can graph all those points, or at least the bulk of them. 1, 0, 2.7, 3, 1.1, 10, 2.3. E is about 2.72, so 1, 2, 3, not quite, and I'll be at 1. 1/2 was negative 0.7, so that's there. And so my points come in, and they're going to ride right along the y-axis. All right, from here, this is a horizontal shift of right 2. That's going to cause you to have a vertical asymptote here at 2. And then I'm going to slide all my points over to the right 2. Good enough. Just get a few of them done. And there's my g of x. All right. For g of x, I'm going to state its domain, its vertical asymptote, and its x-intercept. So if the original intercept was at 1, 0, this new intercept moved 2 to the right, so it's going to be at 3, 0. And again, you should be able to read that right here. All right. That takes care of this video. This is where we ended notes on Monday, November 16th.